Hi everyone, my name is Aaron, and in this video I'm going to show you how to set up MIDI in Sound Reactor Pro. Before watching this video, I recommend watching Sound Reactor Basic Setup. Before you can do anything MIDI related with Sound Reactor Pro, first you have to have a MIDI file. Once you have a MIDI file, you convert that to a .asset file. And to do that, you right-click on the MIDI file, select Create, and then select Sound Reactor, and then MIDI clip. And what that does is it creates a .asset file with the same name as the MIDI file with the extension .midi. The full name is Sound Reactor short.midi.asset, and the .asset portion of the file is removed by Unity. After you've selected the .asset file, you'll notice that it has two properties, a button, and a preview window. Since some DAWs and MIDI sequencers don't export MIDI files with a default tempo, you can supply a tempo here under Default Tempo. Under that you have Preview Track. The preview track lists all the tracks in the MIDI file, and whichever one is selected will be previewed down here in the preview window. Finally, if you've updated the original MIDI file and you want to update the .asset file, you can click on the Reload button. If you've already watched Sound Reactor Basic Setup, you'll notice that the audio source has been replaced by an Audio MIDI Sync game object. This game object has an Audio MIDI Sync script attached to it that's responsible for playing a MIDI source in sync with an audio source. So the first two properties here, if they're left blank, it will attach itself to an audio source and a MIDI source. The next two properties are play on awake and loop, and these are here to control the play on awake and the loop option for the audio source and the play on awake and loop option for the MIDI source. Next you have the sync threshold. What this does, when the MIDI source falls outside of this range, it will either speed up or slow it down to make it stay in sync with the audio source. Next, the playback speed. If you supply a value that's greater than 1, it will increase the pitch of the audio source and speed up the MIDI file playback. And if it's less than 1, it will lower the pitch of the audio source and slow down MIDI playback. Next up is the audio delay. This is here so that you can tell the audio to play after the MIDI has been playing, or vice versa. In the case of this demo, we have the audio playing 0.8 seconds after the MIDI starts. Next is the start time. If there's any silence at the beginning of your audio and MIDI file, then you can tell it to skip that portion. Next you have a debug option. When this is selected, it will print down here in the console whether the MIDI is being slowed down or sped up to stay in sync with the audio source. Finally, we have the play, pause, and stop buttons so that MIDI can be debugged during play mode. Now let's take a look at the MIDI source script. The MIDI source script is responsible for playing the .midi.asset files. In this case, it's pointing to our Sound Reactor short MIDI file here. Next, you have the note offset. The note offset allows you to change which MIDI note is playing. So if you wanted to come down 1 octave, you would tell it to be -12. If you wanted all the MIDI notes to go up 1 octave, you would put +12. Next, you have mute. If this is enabled, the MIDI events stop playing, but the time continues. Next, you have speed. A value of 1 is default speed. Any value higher than that will increase the speed of the MIDI, and any value lower than that will lower the speed of the MIDI. Next, you have your play on awake and loop, which mimics the audio source's play on awake and loop. If you want to handle MIDI events directly, you can create a custom on MIDI event handler so that you can access lower level MIDI events like current tempo, current time, and things like that. Finally, you have your play, pause, and stop buttons here so that you can debug the MIDI playback during play mode. Now let's take a look at the spectrum source. The spectrum source for Sound Reactor Pro allows you to select between two different modes, the audio mode and the MIDI mode. When it's in MIDI mode, you can point the source to a MIDI source. In this case, it's the audio MIDI sync game object that has the MIDI source attached to it. Now let's take a look at the spectrum builder. In this demo, we want to create 3 note emitters that will emit and sync to the MIDI notes found inside the Sound Reactor short MIDI file. In order for this to work right, we have to create or set the levels to 3 levels. And we have to make sure that the frequency range mode is set to MIDI and that the first note is set to the lower frequency and the last note is set to the upper frequency. To get these values, we go to the frequency to MIDI PDF file. And in my MIDI file, my first note is C, my second note is C sharp, and my third note is D in octave 5. So we take 523.25 and type it into the lower hertz, and then we take 587.33 and type it into the upper hertz. And then once we have that, we can hit build. Now we'll have 3 instances of note emitter created as children underneath the spectrum builder called level 0, 1, and 2. So let's take a closer look at what the note emitter is. So under staging, I have my note emitter, and the staging object is disabled so that the note emitter doesn't try to do anything during play mode. So taking a closer look at the note emitter, what it does is it spawns objects that in this case are notes. And the notes can be parented to a custom object. In this case, it's this note emitter. And then you can set the color mode between track or note. So in this case, we're going to color it based off the note. And then since there are 3 notes in our MIDI file, I have this set so that the first note is red, the second note is green, and the third note is blue. And then finally, before this emit note object handler will be called, it has to be attached to an event driver. So the event driver can call custom object handlers or on-level handlers. So to do that, we take our note emitter, drag it into this object, and then we select under the name of the script the on-level handler that exists inside the script. And to make sure that this handler only gets called once per beat, we have to make sure that the on beat is enabled. The last element to consider for this setup is the note game object. The note game object has 2 custom scripts attached to it, which are called translate local motion and self to destruct. The translate local motion script is responsible for moving the note in 3D space. In this case, it moves down to -1 at a rate of 10 meters per second. And then the self-destruct script is what's responsible for destroying the game object in a certain amount of time, which in this case, the timer is set to 1 second. And then once it's destroyed, it can optionally spawn an object and then parent that object to a spawn parent. Now that it's all complete, let's see it in action.